Okay, so this is a key to topic 22, part B, worksheet 1. And in this worksheet, that's where you are describing the end behavior. So the end behavior of each of these polynomial functions. And then it says this, on your paper, just indicate the correct choice. Use the leading coefficient test to determine the end behavior of each function. So the leading coefficient test, okay? All right, so let's look at number 1. So number 1, go ahead and write that function out. So in number 1, we have p of x is equal to 5x cubed minus 7x squared plus 3x plus 4. All right, so if you're going to discuss the end behavior using leading coefficient test, you need to know what the leading term is. So the leading term, and you learned that in a previous lesson. So the leading term is the term with the largest exponent, with the largest degree. So this will be it right here, 5x cubed. All right. Then we saw this. We saw, all right, since the exponent is 3, since the exponent is odd, all right, exponent is odd, okay, and and since the exponent is odd, and since the coefficient is positive, and since the coefficient is positive, the end behavior, the end behavior will look like this. So on the left side, it'll be um, uh, pointing down. And on the right side, the behavior of the graph is going to be pointing up. We don't know what happens between them. There could be all kinds of stuff happening between them, all kind of curves, okay? But at least we know that in the end behavior, if the exponent's odd, just remember the exponent's odd, the arrows point in opposite directions. If the coefficient is positive, the coefficient is positive, then the right arrow points up, the left arrow points down. All right. And remember, in our lesson, one of the things we saw to help us with that was f of x equal x cubed. So remember, x cubed looks like this. That's what x cubed looks like. And so the exponent is positive. You see that? I'm sorry, odd. So right side points up, left side points down. And then since the since the coefficient is positive, the right side points up, the left side points down. When we talked about this, negative x cubed, we saw it look like this. All right, so it's just a reflection about the y-axis. So when we saw, I'm sorry, the reflection about the x-axis. So when we saw that, then notice that the exponent's odd, so the arrows are pointing in different directions. Since the coefficient is negative, the left arrow points up and the right arrow points down. All right. So for number 1, this is the answer you would choose. So you would choose a number 1, this one right here, which is this. So this is the answer for number 1. Okay. So the answer will be D. And number 2, you have this function. You have 4x squared minus 3x plus 2. All right. Now notice the leading term. The leading term is 4x squared. Now notice this time that the exponent's even. If the exponent's even, the arrows point in the same direction. If the exponent is even, if exponent is even, if the exponent is even, either the arrows are pointing up or they're pointing down, just like this. Okay? The coefficient will tell you which one it does. So over here, since the coefficient is positive, all right, so since the coefficient is positive, is going to be pointing up. If the coefficient were negative, remember, let's talk about x squared. So remember, x squared looked like this. All right. So notice that for x squared, the in behavior they're pointing up, and then we saw that for negative x squared, that was a reflection about the x-axis, they're pointing down because the coefficient's negative. All right. So that was in our discussion in those lessons. Okay. So for this one though, since the leading term is 4x squared, the exponent is even, and since the coefficient is positive and the exponent is even, okay, then we get something that's look like this, positive and even. Okay, so the end behavior will be this. All right. Now, in this problem, though, they talk about it in terms of words. So here was in terms of a of a picture, and in here it's in terms of a word. So notice that your choices are it falls to the left, rises to the right, rises to the left, falls to the right, and so on. So notice on the left side, it rises on the left and rises on the right. That's your end behavior. We don't, now this is quadratic, so you know it's going to be a parabola, but this could have been 6, 8, 10, and so on, okay? All right, so we're going to use the one that says rises on both sides. So this is going to be D, rises to the left, rises to the right. All right, so the answer for 2 is D. Answer D. Okay, number 3, let's look at number 3. So number 3, we have h of x is equal to 3x plus 4x cubed minus 7x to the fifth. So your leading term is negative 7x to the fifth, the one with the largest degree, the largest exponent in this case. Okay, negative 7x to the fifth is the leading term. All right. So since the exponent is odd, it's going to be one of these, right? So remember, if the exponent's odd, the end behavior is in opposite directions. So odd exponent, it'll do this. Either it will fall to the left, rise to the right, or it will rise to the left, fall to the right. Okay? So that's what you get when you get an odd exponent, an odd degree. Okay? Now, the coefficient tells you which one it does. So remember, think about x cubed. X cubed rises, remember x cubed with a positive coefficient rises to the right, falls to the left. Negative coefficient rises to the left, falls to the right. So here, notice that the leading coefficient is negative. So it has to be this one. All right. So it has to be this one. So it's going to be this right here. So we got to choose the one that says. So we know it's going to do this. We know it's going to rise to the left, fall to the right. So rise to the left, fall to the right. All right. So that's going to be rise to the left, fall to the right. So find the one that says that. So rise to the left, falls to the right. So that's going to be B. So the answer for 3 is B. All right, so in number 4, we have k of x is x minus 3 times x minus 5 times x minus 2 squared. All right, now think about what we talked earlier. Don't multiply this out. Just look, and what I would do with this one right here is actually write it out twice. So rewrite as k of x equal x minus 3 times x minus 5 times x minus 2 times x minus 2. Okay? And so the leading term, you take the degree of each of those factors. I mean, the leading term of each of those factors. The leading term here is x times, and then the leading term here is x, and then the leading term here is x, and then the leading term here is x. So the leading term is x to the fourth. So the exponent's even exponent. So we have an even exponent. We know the arrows will be pointing in the same direction. The end behavior is in the same direction. So either it's pointing up in both directions, or it's pointing down. So if the coefficient is positive, it points up. If the coefficient is negative, it points down. Okay? So here, for the odd degree, if the coefficient is positive, falls to the left, rise to the right. If the coefficient is negative, rise to the left, falls to the right. Okay? All right, so we found the leading term, so the exponent's even. So since the exponent's even, we know it's going to do one of these. The coefficient is 1, and since the coefficient, the leading, let me say the leading coefficient, since the leading coefficient is positive 1, right? Positive, then we know it's going to do this one. All right, so we point to the uh, left, rise to the left, and then rise to the right. All right, so it's going to be rise to the left, rise to the right. So it'll be this one right here. So it's 4D. So the answer is D. All right. Okay, so let's look at number 5. So number 5, we have this. So we have this function for number 5. We have y equal negative 3x to the 4th plus 5x cubed plus 7x minus 2. So the leading term is negative 3x to the 4th. Okay? Since the exponent is even, the arrows, the in behavior point in the same direction, up or down. The leading coefficient is negative. In fact, it's negative 3. So we know it's going to do this. So it's going to be pointing down. Okay? Now, the problem is that you got to remember the notation. So this notation is different. So remember what this means. This means as y goes to infinity, so meaning as you go to the right, as you move to the right, or so let's say use the leading coefficient to determine whether y goes to infinity or y goes to negative infinity as x goes to negative infinity or I'm kind of as x goes to negative infinity. All right, so as x goes to negative infinity, what that means is this. All right, so as x goes to negative infinity, you're looking at the right. I'm sorry, you're looking at the left behavior. So look at the left behavior. Okay, so remember at negative infinity, as x goes to negative infinity, you're looking on this side. Okay, this is positive, x going to positive infinity. So this is x approaches negative infinity going this way. So you're looking for the left behavior, the left side. Okay, so you look for the left behavior. That's what this means. All right, so this is one you look at right here. So the left behavior is this one here. That's your left behavior. This is your right behavior. Okay, so this is your left behavior. So that says this then. So as x goes to negative infinity, look at what your y values are doing. Your y values are getting smaller and smaller and smaller. See the left behavior is pointing down, so your y values are getting smaller and smaller and smaller. So then y approaches negative infinity. So that's the one you're going to use. So as x approaches negative infinity, so that's your left behavior. Okay, your y values are getting smaller and smaller and smaller. So it's kind of like if you think about this in terms of the grid xy axis. So it's getting smaller and smaller and smaller. All right, so that's going to be this one. Y approaches negative infinity. So 5, the answer is B. Okay. 6, let's talk about 6. And let me go ahead and use another sheet of paper because I may need the room. So this is 6. So in 6, you have so it says use the leading coefficient test to determine whether y approaches infinity, negative infinity as x approaches negative infinity. And so here's your function. So y equals 8x cubed minus 3x squared. So you know that the leading term is 8x cubed, one with the largest exponent. The leading coefficient is positive, right? So since the exponent is odd, and since the exponent is odd, let me remind you, so since the exponent is odd, it's going to do one of these. Point to the left, to the left going down, to the right going up, to the left going up, to the right going down. Okay? Since the exponent is positive, I'm sorry, the degree is positive, it's going to be this one. So we know that for this, whatever the graph looks like, we know that on the left side is going to be pointing down, and on the right side is going to be pointing up. Okay? Now, as x approaches negative infinity, you are interested, what that means is you're interested in the left side. You're interested in the left side. Okay? So that's this one. So this is one you're interested in. Okay? So if you look at this in terms of a xy axis, wherever the graph is, whatever it looks like, on the left side, we know it does this. So as x approaches negative infinity, your y values are getting smaller and smaller and smaller. So this means that y is approaching negative infinity. Okay? Okay. So that was number 6. So let's go back to the problem. So as x approaches negative infinity, on the left side, your y values are approaching negative infinity. So that's going to be this one as well. Okay? So the answer for 6 is B. All right. And then number 7, you have this function, same idea. All right, so this function. So number 7, you have f of x is equal to negative 3x to the 5th plus 4x cubed plus 2x minus 5. And it's saying this though. So which one, now you're looking at both sides this time. See in number 5 and 6, you're only looking at one side. Okay? So this, when you looked at this was the left side, the left behavior, and this as x approaches negative infinity, so again, the left behavior. All right, so this was left behavior. Okay, left side. Over here, though, you're looking at both. So you see that and? So as x approaches infinity, so as x approaches negative infinity or positive infinity, what happens to the y value? Okay, so you're looking at both. So let's first of all talk about the in behavior. So the leading term is negative 3x to the 5th. So since the exponent is odd, right? And the leading coefficient is negative. So what that means is that since the exponent's odd, your in behaviors in opposite directions. Since the coefficient is negative, what happens is that on the left side is going to go up, and on the right side is going to go down. All right, and what that means is this. So now remember they want both. So as x approaches negative infinity, that's your left side. Okay, y approaches. See, it's going up. So all your y values are getting larger and larger and larger. So y is approaching infinity. On this side, what that means is this. As x approaches infinity, so as x gets larger and larger, what your y value is doing? Well, your y values are going down, right? They're getting smaller. So then y approaches negative infinity. And just remember that y means the same thing as f of x. So f of x approaches infinity, or you can say here f of x approaches negative infinity. And all you have to do is just pick the correct choice that goes with what we just discussed. So you got to be careful though as you write this. All right, so let's see which one it is. So as x approaches negative infinity, f of x approaches positive infinity. As x approaches infinity, f of x approaches negative infinity. So we got to figure out which one it is. So be careful. There's a lot of stuff here. So let's see if this is it. As x approaches negative infinity, we said this says y approaches infinity. Is that what this says? Yes. But then now let's check this one. As x approaches infinity, y approaches negative infinity. And that's what this is. All right, so actually it's part A. So just verify the others. Just check the others. So notice as x approaches negative infinity, this says y approaches negative infinity. We know that's not true, right? So as x approaches negative infinity, y approaches infinity. So right away, remember the end behavior. As x approaches negative infinity, y gets larger. So right away you can delete this one, and you can also delete this one, right? Because this says as x approaches negative infinity, y approaches negative infinity. We know that the left behavior, y approaches positive infinity. So it's either A or C. So let's see if it's A. So as x approaches negative infinity, y approaches infinity. That's true, right? Now let's check the other side. As x approaches positive infinity, this says y approaches infinity. That's not true because y approaches negative infinity. So this is the wrong part here. Okay? All right, so the only answer is 7. So you got to be careful as you read this. You got to think through this process. This is not an easy task to get right away. You got to think about this situation here, what's in front of you, to be able to answer this. All right, so the answer for 7 is 8. Okay. All right, so that is. Let me get the first part. So this is the key to worksheet 1, topic 22, part B.